Hello everyone! In the previous tutorial, we programmed a 3D spatial shader, and this time we'll stick to the same concept. In this video, I'll demonstrate how to create a simple outline or glow effect for any 3D object in Godot 4. So let's start by creating a new project. Let's click create and I'll call it 3D shaders because I plan to add more 3D shaders and scenes to it in the future. And I'll change the folder. I think my folder is Godot. Okay, select the current one and 3D shaders, forward. Very well, clicking create. And in the project, I'll prepare folders named materials, models, scenes, scripts, and shaders so that the individual building blocks are nicely organized. Let's do it. Right-clicking the rest, the top folder, and as I said, materials. Sorry, models. Right-click, create new folder. No. Scenes, of course. Where is rename? Here. Right click, create new folder. Scripts and shaders. Fine. Then I'll create the first 3D scene and call it, for example, outline. So right clicking the scenes folder, create new scene. It is a 3D scene. The name outline and create. This time we won't be working only in the 3D editor. We'll also need to run the scene. So to make sure we can actually see something, I'll start by adding a light and a camera to the scene. So right clicking the root node, add child node, and it should be a directional light 3D. Okay, and the camera, adding child node, camera 3D, create. Great. Very well. Let's start building our effect on something simple. I'll add a mesh instance 3D to the scene and set its mesh to capsule mesh. Okay, so right click in the root node again, add child node and the mesh instance 3D. Fine. And in the mesh property, let's set capsule mesh. Here it is. Then we'll just adjust the camera position and direction of the light so we can clearly see the whole object. Right now, when I click camera, we can see nothing. So let's put it back. All right. And I think the light is okay. Maybe we can... No. Let's not make it too complicated. All right. And we can also, I think it shouldn't be just white. Let's add a new material. So clicking the mesh property and here's material property. Let's create standard material 3D. Click it again. And let's set the albedo color for do something red. Okay, this should be fine. Very well. So we can run the project and verify that it displays really what we expect. Running and setting the current scene. Okay, wait for it. Yeah, here it is. Perfect. And I just get rid of this thing. I don't like it. Embed game. Fine. So how do we create the outline? Godot makes it fairly easy because in the 3D editor we can see the button mesh, and when I click it there is the option create outline mesh. Actually, there is also something called the stencil buffer introduced in Godot 4.5, but that's a topic that would deserve its own separate tutorial. For now, we'll stick with a simpler and perhaps easier to understand solution. So let's generate the outline mesh. Okay, here we select the outline size. Let's keep it as 0.05 and clicking create, and it is already there. We've obtained a second, slightly larger capsule, and it's here in the scene tree as a second mesh instance 3D. we can see through it and only the edges are visible. How is that possible? Let's take another look at what the tooltip says for this action. So, selecting the Mesh Instance 3D and Mesh and create outline mesh. Creates a static outline mesh. The outline mesh will have its normals flipped automatically. Okay, so because the new mesh has flipped normals, Godot does not render faces that are facing the camera. We only see the edge because at those points, the faces turn away from the camera, making them visible. It's a simple and quite useful trick. Notice that the outline reacts to light. Here it is darker, here it is lighter. If we wanted the same outline, regardless of environmental condition, we could assign it a material and disable shading like this by selecting the second Mesh Instance 3D and clicking it. And let's create a new material, and it's in here in the surface 0. New standard material 3D, click it again, and in the shading, let's set shading mode to unshaded. And now we can see that everything is still bright white, no matter where the light source is located. Perfect. In practice, however, we probably wouldn't want the outline to be visible all the time. In a game, it would be more useful if we could activate the outline when the mouse cursor hovers over the object. A Mesh Instance 3D, as we can see here in the inspector, does not respond to mouse movement, so we need to enhance it a little bit. Let's add a child node static body 3D to our main mesh right here, adding child node static body 3D. A static body 3D has no dimensions on its own, so it would be useful to add a collision shape to it. As we can see, Godot complains that it doesn't have one, so we'll add it and set it to the same shape, a capsule. Right-clicking static body 3D, add child node, collision shape 3D, and in the inspector, let's set shape to capsule shape 3D. All right, everything should be fine. And finally, we'll need a script to handle mouse events. I'll attach it to the main Mesh Instance 3D, this one. So clicking here and creating a new script, I'll put it to the scripts folder, and let's call it, for example, simple outline. Very well, create. Here it is opened. And I'll drag our outline Mesh Instance 3D into the script while holding the control button, so which created an already declaration. Okay, now I'll select the static body 3D and connect in the inspector. I'll switch to signals and connect mouse entered and mouse exited signals, I mean. So double-clicking the signal, let's make sure it is going to the correct script and clicking connect. And now the same for mouse exited. Too many blank lines here. Very well. So for mouse entered, we'll make the outline visible. For mouse exited, we'll hide it. It is very simple. Let's do it right now. So Mesh Instance 3D, visible is true. And here it would be false. Perfect. And it would also be a good idea to hide the outline at startup. So I'll add the hide command to the ready function as well. Let's copy and func ready and paste. Great. Let's run the project and verify that the outline works. Starting up. And mouse entered, exited, entered, exited. Perfect. So we have a simple single color outline. Let's switch back to the 3D editor. That should work with most basic objects. In practice, though, it would be nice to have something more dynamic, something that glows a bit and maybe even pulses, which brings us to a shader that's simple. And we'll program it right away. So first I'll create a new material in the materials folder so that we can reuse it for multiple objects later. Right-clicking the material folder, creating a new resource, and let's call it, now first we need to make it a shader resource. So shader material, yeah, where is it? Here, shader material, and let's call it glow TRS and save. Okay, here it is, and it should be already opened. Let's switch to the inspector. And I'll add a new shader to it, which I'll save in the shaders folder, right? So clicking here, creating a new shader, type is shader, mode spatial, and the name is glow GD shader, and I'll put it to the shaders folder. Create, and yeah, here it is. I'm clicking again to open it in the shader editor. Okay, and now we have an empty spatial shader, and as usual, I'll start by removing what we don't need so that only the fragment function remains. As usual, deleting vertex and deleting light. Okay, similar to the previous tutorial with the fiery cylinder, this shader will use additive blending. In addition, we don't want the shader to react to light sources, so the next line, render mode, will look like this. Render mode is blend add and unshaded. Okay, so we'll definitely want to configure different types of glow that vary in color, intensity, pulse speed, and so on. So for this purpose, I'll add 5 uniform parameters. Uniform vec4 glow color with a hint source color to give us that nice color picker in the inspector shader parameters. And let's start with something, I think it would be bluish or greenish, 1 and 1. All right, then the intensity, uniform float glow intensity with hint range and the initial value, for example, 2, and the hint range can go from 1 to 10 with the step point 0.1. Then the sharpness at the edges, glow sharpness, again with hint range, and again it starts at 2 and goes from 0.1 to, for example, yeah, let's use 10 again, and the step point 0.1. The fourth one would be the pulse speed, uniform float, with another hint range and starts at 1 and goes from 0 to, let's say, 5. And no, let's make it 10 again with the step point 0.1. And finally, the strength of the pulse, uniform float pulse strength. Hint range, and this time I think the default value is set to 0.3, and it goes from 0 to 1 with the 0.01 step. Okay, and now let's start coding. First, we'll define a variable called Fresnel, which is written as Fresnel, which ensures that the effect is brighter on the edges and transparent elsewhere. Exactly what we expect from an outline. In the fragment function, let's write it, float Fresnel is power of 1 minus absolute value of dot product of normal, the internal variable, and view, another internal variable, and to the power of glow sharpness. Okay. If this formula looks familiar, it's because I used the same principle in one of the very first shaders I demonstrated on this channel. Next, we want an animation in the form of color pulsing, which we'll achieve using two additional uniform parameters. So float pulse is 1 plus pulse strength times sine for the regular periodic pulsing, times pulse speed, and times pi. All right. And finally, we'll calculate the alpha value, which will control transparency and emission strength. Float alpha equals Fresnel times glow intensity times pulse. Perfect. All that remains is to assign the results to the output variables, which in these spatial shaders are three: albedo, alpha, and emission. So albedo equals glow color and RGB components, because albedo is vector 3, but glow color, as we can see here, is vector 4. And alpha equals alpha, which we already calculated, and finally the emission, because we want the outline to glow, is glow color dot RGB multiplied by alpha. Okay, and we are done. In the inspector, we can already see a preview of how this shader would look on a sphere. We can adjust the parameters and observe how they affect the final effect. So hit the parameters. Now if I change it to something like magenta or anything else, we can see it reacts to the color changed, glow intensity. Now it's more intense, now less. Sharpness, it defines the sharpness. Pulse speed, let's make it pulsing faster or stop it completely. And the strength. All right. So let's return to the outline mesh instance 3D, which is this one, and replace its material with a new one, which would be a shader material. So where is it? Here is our material. Let's create a new shader material, and let's drag our new shader to the shader property. Okay, and here it goes. In the 3D editor, we can observe how the outline indeed pulses and has blue color. So let's do it, starting the project, and here when I move my mouse cursor into it, we can see the new outline, and mouse exited and it's gone. Perfect. Okay, so I think it's quite a nice result. However, in a real game, we'll most likely be working with complex objects, and it will probably be tedious to manually create an outline mesh for each one. So let's take a look at how we can automate the entire process using a script. So I switch to Blender 501, and let's create a nice looking asteroid. So here I'll select everything and click X to delete the whole scene. And now for the asteroid generation, you need to have this plugin activated, edit preferences, add-ons I mean, and extra mesh object. If it's not here, just find it. It's a standard add-on and activate it. So now I can use Shift A and create a new mesh, and here there should be extras folder and the rock generator. Now I created a simple rock, but let's make it a little more interesting. So I'll expand this menu and change the preset to asteroid. Now it looks much better, and I think we can work with that. Actually, it has almost 50,000 triangles, but for the sake of this tutorial, it doesn't matter too much. So let's just switch to UV editing, and we can see that most of it is created through modifiers. So I'll switch back to layout and open the modifier section, and now I keep clicking Ctrl A to apply them. So now we have the real object here. When I switch back to UV editing, we can see that it has all the triangles, all the faces. Let's select all and go to UV and choose Smart UV Project and unwrap. Now it's wrapped. Actually, we won't need that because I'll use a triplanar mapping in Godot, but well, doesn't matter. Okay, and now File and Export to GLTF 2.2. In the everything can stay as it is, and I think I need to put it to our folder, which should be where? Oh, let me find it. C users Philip Godot and 3D shaders and models. Okay, I'll call it asteroid.glb. Exporting. Okay, let's check Godot. It should automatically import it in the models. Here it is. Double click, and yeah, here is our asteroid. Great. I think we can close Blender now. All right, but the asteroid doesn't have any materials, so let's create one. And by creating, I mean just starting the material maker and export the free material called moon. Let's wait for it. Okay, and here file, load material from website, and when it's ready, now filter moon. Here it is. Okay, now it's opened, and I'll just export it for Godot. Godot and Godot 3, Godot 4, I mean standard. All right, and again, we are in the materials. Yeah, but wrong project, sorry. 3D shaders and materials, and exporting as asteroid. Is it asteroid? No, sorry. Asteroid TRS. Okay, exporting, and it should be there. Let's close the material maker. And our material is right here in the materials section. So I'll just double click asteroid TRS, and as I said, I want to make it triplanar mapping because otherwise I think it will look a bit better. All right, and let's just hide this mesh instance 3D, and where is the model here? Asteroid GLB. So right clicking and new inherited scene. Here it is. I'll select the rock, the mesh, and go to surface material override and drag our asteroid TRS material into it. And now we have a nice looking asteroid. Perfect. So let's save it, Control S, and I'll put it to the, of course, to the scenes section folder because it is a scene asteroid TSCN. Great. Okay, so of course you don't have to do any of this. You can use your own model. I'll return. Okay, and the scene of course needs a script, so we'll attach one to the root node. This is the root node, attaching asteroid GD and put it to the scripts folder. Create. And again, just like with the previous capsule, we'll add a static body 3D and a collision shape, which this time I think I'll set it to a sphere. So right-clicking the root node, creating a static body 3D, and adding a child node into it, collision shape, which I set to sphere shape 3D, and I think it should be a bit bigger. Let's try 1 meter, not big enough. 2. Maybe too much, 1.8. Yeah, this one is fine. Okay. So, and for the static body 3D, again, let's create callback functions for mouse events. So signals and mouse entered to the asteroid script, and the same for mouse exited. All right. And now let's write the rest of the script. We'll need 3 variables: mesh object, outline object, and outline material. So let's put them here, var mesh object, which is mesh instance 3D. Okay, and I have to copy paste twice and rename. So the second one would be outline object, and the last one outline material. Of course, material is not mesh instance 3D. It will be shader material. Perfect. And to avoid hard coding anything, we'll assume that the mesh object is the first node of the type mesh instance 3D that we find, which would be in this case the rock node. So I'll write the corresponding code in the ready function. Func ready, and let's iterate for node in all child nodes. If node is mesh instance 3D, we found our mesh. So mesh object mesh object is our node. Great. Of course, it could also be done differently, for example, by adding the correct mesh instance 3D to a specific group and then searching by that group's name. Now, sorry, now I'll create the material for the outline like this. Again, still in the ready function. Outline material is a new shader material. Shader material dot new, and let's assign our shader into it. So outline material shader is load, and I will drag the shader into this load function, and here it is. Cool. Next, we'll implement outline activation and deactivation. When activating, we'll create a copy of our mesh, assign the outline material to it, and add it as a child node. So this is the function, the mouse entered callback, and outline object is, again, mesh instance 3D and new. And we want it to share the same mesh, the same asteroid. Then we'll modify it a little bit. So outline object mesh equals mesh object mesh. All right. And let's assign it the material we created in the ready function. So outline object set surface override material, and now since the object can have multiple surfaces, we need to use an index, and it is 0 because there is just one surface, an outline material. Okay, and of course the outline object was created, but it's not visible because we need to add it to the scene. So mesh object, it will be the child node of our main mesh object, add child outline object, this. All right, and for the activation, I mean, we'll simply remove the child node. So mesh object, mesh object, remove child, outline object. Okay. So let's return to the main scene, which is here, the outline, and add the asteroid to the road node. I think I'll switch to the 3D view, and our asteroid scene is here in the scene folder. I'll just drag it to the root node, and here it is. And let's check the camera. Back to inspector. Wait for it. Okay, I think we need to move it a bit further away. Yeah, this is fine. Okay, and let's run the project. Running, and here's our asteroid. Can you see when I just move the mouse into it, it's perfectly highlighted and it pulses. Very nice. let's close the project, I mean the running instance. But objects in a game will move, of course. For example, the asteroid should rotate. Let's verify that the outline also works when rotating around the y-axis. So I'll get back to the asteroid scene and switch to the script. And here I'll add the process function. Func process and a simple rotation. Rotate y and delta for the angle. All right, let's start it again. Now it's rotating, and so is the outline, the highlight. In, out. Excellent. So let's make a few more improvements. We should be able to set the outline size individually for each object, as well as different shader parameters. So I'll add 3 exported variables. Let's get back to the top of the script and add them here. Export, this export var scale factor, which is a float and starts at 1. Then export var glow color, that will be a color, and the initial value, let's make it the same as we have in the shader. So color 0.3, 0.6, and 1. Yeah, this one. Now we can see it here in the tooltip. And let's also customize the intensity and power of the glow. So export var glow intensity, which is again a float value and starts at 2, and finally export var glow power, again a float, and again starts at 2. Okay, so we should, when I select the root node, we should see them here in the inspector. And now let's use them. In the ready function, let's configure the shader. So let's continue here. Outline material, set shader parameter, and the first one is glow color. I'll just copy and paste to make it faster, and glow color as the value, and let's do the same for the rest. So copy paste twice, glow intensity and glow power. Fine. And now at the mouse entered function down here, let's add a scale change according to the new parameter. So just before adding to the scene, let's do this outline object. Scale is vector 3. Let's make it a uniform scale so it would be the same in all dimensions. Scale factor and 3 times. Okay, very well. And to test it, let's add multiple asteroids to the scene, change their sizes, and assign different parameters to each one. So I'm switching back to the outline, the main scene, and let's switch to 3D editor. And now asteroid, where is it here? So I think I can duplicate it and move the first copy here. And I think we could make it a bit smaller. So opening transform scale and dragging to make a smaller asteroid and put it up a little bit, and then duplicate again. And this one could be here, and let's move it a little bit lower and perhaps make it a bit bigger. Yeah, let's see if the camera can actually see all of them. Almost. So let's move this one here and this one over there. Try again. That's better. I think this one can be still moved a little bit to the right. Camera. Yeah, that should be fine. Okay, and the other parameters. So the first one can stay as it is. The second one, let's make it green and increase the intensity and decrease the power. Alright, and make it bigger, so scale factor. Okay, and the third asteroid, we can let it glow in orange. And let's just keep it as it is and start the application. Now, the first one, we can see how the glow is bigger, the outline, than the asteroid itself. This is our main asteroid, and this one is yellow. I think everything works perfectly, and it's pretty customizable. Let's get out of that. Thank you very much for watching, and I hope this simple technique will be useful too. When developing a game, we can of course choose a different way to activate the outline, for example using Raycast 3D or as a response to keyboard shortcuts. And if a more complex object consisted of multiple Mesh Instance 3D instances, we would simply enhance the script to assign an outline mesh to each of them. I believe the basic principle should be now clear, and if not, feel free to ask anything in the comments. For now, take care, good luck with developing your games, and I'll see you in the next video.